Hi, I'm Ashley Pierce, and I'm going to show you how to go from a improper fraction to a mixed number. So we'll start with an improper fraction, or a fraction greater than 1, because it's not really improper to have the numerator larger than the denominator. But I'm going to start with 10 over 3. Alright, so I can tell that this is an improper fraction, or a fraction larger than 1, because numerator and denominator, the numerator is the same as or larger than the denominator. Okay? So what I like to do for this, I like to do a visual representation first, and then I will do the algorithm for it. So since my denominator is 3/3, I'm going to cut some squares into thirds. I'm going to draw a few of them. I'm not sure how many I'm going to need. Alright, so now I have 10 thirds, so I'm going to shade in 10 thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now I'm going to look and see how many whole rectangles I have shaded in. I have 1, 2, 3. And then I have one more rectangle where 1/3 is shaded in. Right? So that's a visual representation of how to go from an improper fraction to a mixed number. Okay, now I'm going to do the algorithm for the same problem. So when I think about a fraction, I could also think about it as a division problem too, where the denominator divides the numerator. So when I set it up in the division bracket, I'm going to put the denominator outside and then the numerator inside. So now I'm going to see how many times 3 can go into 10. 3 times 3 equals 9. So that means I could put 3 3s into 10. And then I'm going to have 1 left over. And that remainder becomes the numerator of the fraction part of my mixed number, and the denominator stays the same. So that is the algorithm, or the mathematical way of going from an improper fraction to a mixed number. Now I'll do that again for another problem with a different denominator. Alright, so let's say that I have 7 halves. Alright, so I'm going to start by drawing my rectangles. I'm going to draw a few of them because, like I said before, I'm not sure exactly how many I'm going to need, but if I have more than I need, that's not a big deal. And then I'm going to partition each rectangle into halves. Now, since I have 7 halves, I'm going to shade in 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. So I got a bunch of rectangles I don't need, but that's okay. I can just cross them out. All right, and then I'm going to count and see how many whole rectangles I have shaded in. I have 1, 2, 3. And then I have 1 half. Now to do the mathematical algorithm for it, I'm going to set it up like a division problem. 2 is going to be the divisor, and 7 is going to be the dividend. So I'm going to see what I can multiply by 2 to get as close as I can to 7 without going over. So 2 times 3 equals 6. 2 times 3 equals 6. Nope, that's wrong. All right, so I'm going to do this again for another fraction. I'll do 7 halves. So I'm going to do the visual representation first. So I'm going to draw some squares, some rectangles, just draw a few. Might not need all of these, but if I have some extras, that's no big deal. And then I'm going to go partition each of these into halves, because that's what my denominator is. All right, and my numerator is 7, so that means I have 7 halves. I'm going to shade in 1, 2, 3, 4, 5, 6, 7, and I have these extra ones I didn't need, so I could just scribble them out. So then I'm going to count and see how many whole rectangles I have shaded in, and I have 1, 2, 3, and 1 half. Now to do the algorithm for this, I'm going to set up my division bracket. I'm going to put 2 as my divisor, because that's the denominator, and 7 as my dividend, because that's my numerator. See how many times 2 goes into 7, and it's 3, because 2 times 3 is 6. And I'll see what my remainder is. And my remainder is 1, so that becomes the numerator part of the fraction part of my mixed number. And then the denominator stayed the same. So 7 halves equals 3 1/2.